Thank you for joining us for the North Central IPM Center's Pest in Progress webinar series. My name is Jackie Pohl, and I'm the communications person for the North Central IPM Center, which is one of 4 regional IPM centers supported by USDA NIFO's Crop Protection and Pest Management Program, which is part of the Regional Coordination Program. The mission of our center is to coordinate IPM across the North Central region by sharing and promoting IPM research, extension, and teaching activities. If you have questions during the webinar, please type them in the Q&A at the bottom of your Zoom screen. Our speakers will answer questions at the end of the presentation. The title of today's webinar is Using Social Network Analysis to Understand Pest Management Practices of Vegetable Growers in the Great Lakes region of North America. And it is my pleasure to introduce Dr. Elizabeth Long from Purdue University and Dr. Carlo Moreno from the College of Worcester. Thank you so much for joining us today, and I'll turn it over to you.
Okay, thank you so much. I'm Elizabeth, and I'm going to get us started today. We're going to split this talk in 2 parts and hopefully keep it moving along here so you all stay interested. And since we've already heard the title of the talk, I'll just add that, we're going to be telling you all a little bit today about the North Central IPM Critical Issues Grant that we got funded back in during the pandemic. And so we're excited to share some of those results with you today, again, focused on this social network analysis to understand pest management practices of vegetable growers in the Great Lakes region of North America. Whoops, if I can get my slide to advance. Okay, so just wanted to provide a brief outline. I'm going to start us off with the study system and our focal pest, in this case, the carrot weevil. I'll very briefly walk you through the biology and life cycle and why that matters. Then we'll talk a little bit about investigating management strategies, which was kind of one of the primary objectives of our proposal, particularly focused on delayed planting as a strategy to manage this pest. And then this third point here, I will pull the plug on myself and turn it over to Dr. Moreno so he can tell you about what we've learned in terms of investigating the knowledge networks of specialty crop farmers. So jumping right in here, my introduction to this pest, to the study system, is really through farmers who reached out to the university, to University Extension, to ask for help managing a pest. And so that's how I first learned about the carrot weevil, which we'll learn about a little bit more on the next slide. But it's a major pest, particularly in the Great Lakes region, where these lovely and nutrient-rich muck soils are common, and we see a lot of specialty crop production on these soils. And this weevil tends to be a problem in parsley, which is what we'll be talking about today, but also carrots and celery, grown particularly on these soil types. And while it may be a relatively niche pest or a narrow pest that some of you haven't heard about, it's really important for these farmers because it can really damage the crop. And for those of you who may know about fresh parsley or not, whether it's one of your favorite ingredients as a fresh herb, this is a really valuable specialty crop. Farmers can earn anywhere from $9,000 to $12,000 an acre growing this crop. So this pest is an important one for us to understand and manage. So why is carrot weevil such a challenge? Oops, I see something hasn't animated in here yet. Well, there's several reasons, but I think I can boil it down to 3 key points for those of you in the audience who may not be familiar with this insect. So first is that it's a cryptic pest. And by that, I mean, you can see the adult here. Here's a handsome weevil. It's darkly colored. You can imagine how well it camouflages into the soil on these black soils, or these black muck soils that, again, a lot of these specialty crops are grown on. It's a native pest. So it's adapted to our region here in the Great Lakes region. Cold winters, spring rains, not a problem for this weevil. May slow it down a little bit, but it's adapted to do well. And we see that continues to be an issue over decades, almost 40 years of work now at this point, trying to understand this insect on these particular soil types in our region. And the last reason is that the adults are active throughout the season. And so there's a long window of time where we have to protect the crop against this insect. And it's challenging to do because it is cryptic, not just as an adult where it's well camouflaged, but the eggs are actually laid inside the petioles of young plants. And you can see that here is this little black dot. That's an egg scar that the female has chewed, laid several eggs inside and then closed up to protect against other natural enemies. And then she walks on and lays eggs in more plants as she kind of encounters them in the field. And they're out there active early in the season, late March to early April, all the way through the harvest point, which may be as late as September. So we've got a cryptic pest, a native pest, and a pest that's active season long that has the potential to damage these crops. So focusing in more on the damage by this carrot weevil, the larvae are the truly damaging life stage. And I say that for two reasons. One, you can see here in the root system of a parsley plant, the larvae get pretty large and they tunnel actually down through that petiole, in through the crown and to the root. And if this happens early in the season to young plants, whether it's carrots, parsley, or celery, these plants are destroyed. Their root systems are very small. They're not very developed. They don't stand a chance against the damage inflicted by these larvae as they move down into the root system. If we think about carrots pictured here, but also celery, if the plants do survive to produce the marketable part that we're interested in eating and of course selling on the farm from the farmer's perspective, this damage that's caused here by the larvae as they tunnel through and feed renders the crop totally unmarketable. I mean, no one's buying these at the grocery store. Am I right? They're not even going to make it there. So this is an important kind of damage that the larval stage in particular causes, not just to the plant's survival, but to the marketable part at the end of the season. And here's an example of a parsley field in Ohio around early August, and you can see what should be a lush, full beds here where we can't see the soil. We actually see lots of soil is exposed. This crop this particular year has been devastated by the carrot weevil. And as I mentioned, there's been decades and decades of research focused on this pest. And if you look into the literature pretty closely, really what we see is that there's been a heavy reliance on foliar insecticides. And despite the new products that we have and the different strategies we have for the timing and applying these insecticides to manage this insect, we really see limited to poor protection. And so that really tells us we have more work to do, more we need to understand about this insect to improve management for the farmers and to improve their bottom line. So I'll just walk you very briefly through the carrot weevil life cycle, just to give you a sense of what we're up against and how this insect kind of moves through the crop. Early in the season, as I mentioned, late March to early April, the adults are out, and the adult stage is the stage that overwinters. So they survive the winter as an adult. They emerge late March to early April, and they're walking around out there in the fields when there's no crop present, which is bizarre, but that's what they're doing. There may even be snow on the ground, and they're still kind of walking along aimlessly, it seems. Once the crops germinate, they actually walk to new fields or new plantings, whether it's the same field or an adjacent field. And as I mentioned before, the females hone in on young plants, roughly 3 to 4 petioles or true stems. Around that stage of the plant, she begins to chew holes that you can see here and lay eggs inside, anywhere from 2 to 10 eggs. And then she covers it with this black anal secretion, again, to protect the eggs from parasitism or attack by other insects and natural enemies. So 5 to 16 days later, this happens more quickly when it's warmer, more slowly when it's cooler. 5 to 16 days later, we see those eggs hatch into larvae. And there's actually 5 larval stages, or instars as we call them. I only have 4 pictured here because the first instar is really tiny. But as with many other insects, here we have the second, third, fourth, and fifth instar. These larvae just feed more and grow bigger as they progress through those life stages. Again, this occurs more quickly when temperatures are warmer. And when they finally complete the larval development, they'll enter the pupal stage, which is this pre-adult stage. You can see 2 pupae here in the soil, the muck soil in my hand. Here's a nice close-up image of what that pupa looks like. You can see it's taken the adult form and is just waiting to emerge. And eventually this process repeats when the adult emerges. I should say the pupae occur in the soil, and then they emerge, crawl to the soil surface, and this whole process starts again. So there's one generation, generally speaking, takes 30 to 40 days to develop. And in our part of the country, I should say in Ohio, in the Great Lakes region, we see 2 overlapping generations per year. And I have overlapping here in purple because that means you can actually see the adults, you can find eggs, larvae, and pupae all at the same time during the season, during a typical production season. And as you can imagine, that can make it challenging to know when do we take action against which life stage, right? They're present there, and you may find all of them at that particular at multiple points during the season when you're trying to scout the plants and figure out who's there and when you should take action. So I've told you all about the carrot weevil, well, maybe an abbreviated background about the carrot weevil, its life cycle. Now I want to tell you about the IPM strategies for carrot weevil. And this is to set the stage for one small element of this approach, or this one of these strategies that we pursued in our research. So if you look in the literature again, there are some key things that are recommended. The first is to rotate fields a quarter of a mile away from previous plantings. And some of you may be thinking already that that might be challenging to do. And in fact, we do hear from farmers that it is challenging because you may not be able to move that distance away from a field that was in parsley if you have multiple fields in a given year. But this is the recommendation mainly because there's limited evidence that the adults disperse by flying. So a quarter of a mile is a pretty long way for these weevils to walk along and infest a new field at that distance. Another recommendation we see in the literature is to delay planting. And this is not just for the carrot weevil. You've probably heard this for many other insect pests. And the idea here is that if we delay planting, then we delay that period when the adults are overlapping and overlapping with the vulnerable stage of the plant. So if we delay that, we reduce essentially the temporal overlap when these two are interacting, the plant and the insect, so that damage can be caused. And I have this highlighted here because we'll talk about this a little bit more in the next slide. Some other key strategies that are so critical, but maybe a little time intensive, are to monitor overwintering adults with these carrot-baited traps, and that's what I have pictured here. And I just want to point out this trap is not a trap that kills the adult weevil. It simply provides something delicious that smells like a food resource early in the season, when again, there's no crops germinating in the field. So the weevils basically come to this trap that you place on the edge of the field, and they smell the carrot. They walk into the trap either through the ends. There would normally be a cover over this, so you wouldn't see the carrot, just for the record. But so the adults are entering through the ends of this trap or through these little tight grooves, and they have a behavior where they like to be in a tight and closed space. So they come to the trap, attracted by the smell of the carrot, and then they just hang out there. And that makes it a great monitoring tool for farmers, rather than walking around in the field hoping you pull up the right plant to find the adults in the soil or wherever. You just place these traps and you open them and you look and see if they're there feeding on the carrots. This works early in the season before the crops germinate. However, we found over the last several years of research, once the field starts to grow in and look really dense like we have here in this #2 picture, the adults essentially disappear. They no longer come to the traps. And we think that's because, why would you come to a single carrot in a trap when you have a whole field of deliciousness emanating these aromas that are what are actually attracting the adult weevils? So once the crops germinate, you switch strategies and you no longer monitor the adults. Instead, you go and you look at the plants, the actual petioles of the plants, and look for signs of egg scars. And the recommendation currently is to create an X-shaped transect in the field. So two equally shaped or linked, two transects of equal length that cross in the center, so we can look at the edge relative to the interior, and scout 150 plants at random along those two transects. And if you have anywhere, anything more than 1% egg scars, which is really just one egg scar on any of those plants, the recommendation is to take action. So you can probably imagine folks might be more inclined to just spray if they feel the weevil is there, rather than scouting all these plants, because it's time intensive and requires lots of squatting. So of course, when we talk about IPM, hopefully you've done these cultural strategies, you've used your monitoring tools, you've scouted for pressure, and then as a last resort, you break out the tools to manage the insects if necessary. And in this case, for the carrot weevil, almost 100% across the board, that requires the use of insecticides that are foliar insecticides targeting the adults, or systemic or soil applied insecticides that are taken up through the roots that target the larvae. Because again, the larvae are inside the plant, they're protected from most foliar active ingredients that you would be spraying. Last but not least, at the end of the season, we know that these weevils are still present in September, October, when things are finished up in terms of the crop. And they are native, so cold weather is not going to stop them from living life. We recommend that you disc the crop residue at the end of the season, and basically taking equipment through, chopping up all the plant material, any life stages that may be there, the pupae, the larvae, the adults, physically destroy these insects so that they can't contribute to the next generation. So there are many recommendations out there. Most of the key ones I've listed here on this slide. But we still hear from farmers, not just in Ohio, but also in Michigan and certainly in Canada, that this weevil continues to be a challenge. So that raises the question, is there something that we don't know that farmers are doing that may be successful against this pest? Maybe there's nothing that's successful and we're just not well connected enough, or farmers are not well connected enough to communicate what they're trying, what's worked, what they would like to see attempted as a management strategy. So that really raises again this question: how are farmers making decisions about carrot weevil management? Are they talking to each other? Are they sharing information with each other about what works or what doesn't? It also raises questions about, are the published recommendations effective at commercial scale? And I bring up this question because, a lot of the work at any land grant institution or institutions that have extension services, we're often working on a research farm, right? So the scale may not be the same. Some of the pressures and requirements may be different than what farmers would be experiencing at the commercial scale. And then I won't talk much about this third question here, but wanted to raise it as well because it is really important, particularly for the farmer. What are the economic costs and benefits of these various IPM strategies? Is it worth it? Does it benefit my bottom line to actually engage or implement these strategies, knowing that they may have limited efficacy or not? And so the key strategy we pursued in our proposal to our critical issues grant was this idea of delayed planting. And in the literature, it has been suggested that delayed planting can really help reduce that egg laying pressure by the overwintered generation of carrot weevils on the crop. And so when we talked with farmers about this, our collaborating farmers, we asked, would you be willing to try delayed planting? And they were willing, but they had some concerns. And some of the farmers that we talked to indicated that they view this as a risky practice. And that's because carrots, parsley, celery, these are, they have very small seeds. They have a really thick, oily, and heavy coat. So they really rely on these spring rains in our region of the United States to soften up that seed coat and improve or, move germination forward more quickly because temperatures are cool at the time of year when they're seeding, which is late March, early April. So they view delayed planting as a risky practice because they might miss that spring rain event that would help the crops germinate more quickly. But aside from that concern, we wanted to ask, well, let's test it. Let's partner with these farmers and go out to their farms, identifying fields that have had issues with carrot weevil in the past, and basically test this empirically with the farmers on their own farms. So our key question was, can delayed planting reduce carrot weevil damage in fresh parsley? And our prediction was that, again, reducing that overlap between adult activity and the vulnerable crop stage, right around the time there are 3 to 4 true stems or petioles, our prediction is that that would reduce the egg load in the young plants because we would reduce the overlap, again, reduce exposure to the pest when the plant is vulnerable. So I have images here of the spots of the 2 farms that we worked with. And so we were able to work with them to identify fields that were planted 2 weeks later than the other fields. And this was just based on what was available that year. We did our best to work with them. And this was what the best they could do is delay planting by 2 weeks, although there was a field that was delayed 2 months in a single case. And these 6 fields, 3 from each of 2 farms, we scouted those 6 fields for 7 weeks throughout the season. And again, we set up those transects and counted the number of egg scars on 150 plants in each field, again, on that X-shaped transect from the interior to the edge. And just for the record, the field sizes range from 3 to 9.5 acres. And these farms were growing both curly parsley and flat parsley varieties. So you can see here, some of these fields, this is all beautiful muck soil, lots and lots of vegetables being grown on the landscape here. But here you can see some of the locations of the fields and just their general proximity to each other on the landscape. Okay, so in the interest of time, I'm going to jump straight into the results. And I was a little bit disappointed to find that we didn't see evidence that delayed planting reduced carrot weevil pressure as measured by egg scars in this one season. So just to break this down a little bit, on the y-axis here, I have the mean number of egg scars that we found per parsley plant out of those 150 that we scouted in every field, each of those 6 fields. And then along the x-axis here, the 7 weeks that we did that scouting. And it's pretty clear here that there's no difference between the dark the dark line or the field circles here, those are the fields that were planted at the typical schedule. And then the open circles being those fields that were planted 2 weeks later. There's no difference whatsoever in the number of egg scars on those plants as we look through the season. The pattern is as the season goes on, more eggs are laid, and we see those accumulating at a similar level or similar rate, if you will, based on these data. So it's a little disappointing, I have to admit. But maybe in some ways I'm not too surprised because on the one hand, maybe 2 weeks wasn't quite enough of a delay to see a difference. I also have here as the first bullet point that delayed planting may be ineffective in this particular system because, again, these female weevils are capable of laying eggs throughout the entire season, and they have lots of eggs to lay. So when you have, one or two that can cause damage and kill a plant, maybe this is not the system where we would see delayed planting benefit based purely on the insect's biology and seasonal phenology. We didn't find evidence that delayed planting was risky, at least not in the particular year that we did this work. And maybe, that's not surprising, but if it was a typical year, if it had been really dry, or maybe rains had been a little late, we may have seen some reduced stand or plants not look or fields not looking as good based on crop germination. However, we did see some evidence that what farmers do matters. And this is like me priming you all for this section that Carlo's going to be talking about in the next slide. So here, if we look at the mean cumulative number of egg scars, and by here I mean cumulative number, if we total the number at the very end of the season on the two farms, remember there were 3 fields on each of the 2 farms that we scouted. What we see is a significantly higher number of egg scars on farm 2 here, if you will, versus farm 1. And this is really interesting because they provided their records to us. We know what they were spraying. We know how many times they were spraying, but we still see a difference here in that cumulative number of egg scars in fields on their farm. And this suggests that something's different. They're doing something that matters. And maybe they are sharing information, but maybe they're not necessarily following the same IPM practices, either at all, or maybe they're not following the same practices or utilizing those same practices at the same time. And timing can be really key when we're up against managing a difficult, challenging pest like this carrot weevil. And sometimes it can be one person at the farm who plays a pivotal role in pest management outcomes. And I bring this up because there's another farm in Hartville, Ohio, that we were also in communication with. This has been many years ago now, but there was a person who was in charge of all the IPM strategies for pests, and carrot weevil was at the top of their list, and they always rotated a quarter of a mile away from the previous field. And they had very, very little pressure, very few problems with carrot weevil. I would call them and, ask if I could come out there, what could I do? And they're like, oh, we're good. So this is really, really important. I think it highlights that, one person who keeps strong records, who can really drive decisions to do this one key practice, in this case, rotating a quarter of a mile away, can make a huge difference. Okay, so hopefully I didn't move through the first 2 bullets here too quickly, but I hope I've set the stage for the system we are working in, some of the questions that arose about the integrated pest management strategies that specialty crop farmers are using. And now I'm going to turn it over to Carlo to talk about investigating knowledge networks of specialty crop farmers. And for those of you who may have some burning questions about carrot weevil or anything that I talked about in the first part of the presentation, please do go ahead and type your questions into the Q&A so you don't forget, and we'll come back around and answer those questions at the end. Okay, so I'm going to stop my share. I'm going to turn it over to Dr. Moreno.
Thank you, Elizabeth, for that passing of the baton. We've now reached intermission. Before I start here, I'm going to share my screen here in a second. I want to just give another brief introduction of myself. My name is Carlo Moreno. I work at the College of Worcester, which is a select liberal arts college in Northeast Ohio. I want to believe you are all seeing my screen here. I really want to pick up with one of the last points that Elizabeth brings up, in that what farmers do matters. And that's something that we've seen time and time again, that management practices are important. But here's a burning question that comes up, and this especially comes up from the academic side of this issue, and that is, we have all of this research-informed strategies for managing pests, but what good is it to have all these strategies, to make all these recommendations, if ultimately they are not adopted? And so really the question that I'm looking to ask as we start this portion of the talk is, what influences whether or not people, you and I, farmers, adopt a practice or not, right? And so what those people who study human behavior have found is that one very simplistic way of thinking about this is, well, we make our decisions on adoption of new practices based on the perception of risk that we see in adopting that practice or not. And so as it stands, if you perceive a high amount of risk for a new practice, you are less likely to adopt it. And if you perceive a low amount of risk, you are more likely to adopt it. Now, this is just a simple heuristic that has been developed in the last 50 years for thinking about, behavior, human behavior, decision making. But more recently, people in the world of social psychology have said, well, it's not just perception of risk. You need to look into something called social learning. And social learning, to explain what that is in just a few words, social learning is just learning by watching or imitating or listening to others. This term of social learning was coined by a social psychologist by the name of Albert Bandura in the 60s. And for those of you who don't know, this is just kind of a fun little fact. The idea of social learning came from the Bobo doll, what's called the famous Bobo doll experiment, in which children ages like 7 through 10 were given Bobo dolls, and they had never previously seen a Bobo doll. If you don't know what a Bobo doll is, like picture this inflatable kind of bowling pin looking plastic doll that's inflated, and when you hit it, it comes right back up. And so kids were presented with this Bobo doll. One group of kids was left alone in a room with the Bobo doll, and they just kind of observed the behavior of the children. A lot of those kids had no idea, because they had never seen this toy before, had no idea what to do with the doll. Some of them were observed just losing their interest in it and just staring into the corner of the room. Others were observed talking to the doll. Now, in another experimental group, a different set of children were again presented to the doll, and within about 15 to 20 minutes, an adult walked in the room and immediately started punching and kicking the doll. That's kind of what you're supposed to do with those dolls. And what they observed is that those children that watched that behavior were more likely to start doing the same thing. So the idea here again is that there's a great deal of learning that takes place in just a simple act of being with other people and observing their experience doing something. That modifies this heuristic, because through social learning, our perceived risk can lower, and that could influence us to adopt a new practice. Okay? This is something that's been studied time and time again in the world of social psychology. So I bring all of this up to really bring up the question of, well, what is the role of social learning in IPM adoption? So again, in taking this back to what Elizabeth was saying, what farmers do matters, but what is the role of interpersonal communication in whether or not these farmers or producers are more likely to adopt IPM practices? So we had two sub-questions within this question that we're looking to answer with this study. The first one is, let me get to that here in a second, should pop up. Who are the key informants of IPM knowledge in social networks? The second question that we're looking to answer is, do producers with larger networks of informants adopt more diverse IPM practices? This question is really based on an assumption we're making that people who receive information from varied sources are more likely to adopt varied practices for managing pests. So kind of an intuitive assumption we're making. Now, let me just get through this right here. Now, I want to spend a little bit of time. I know that running short here on time, but I just want to spend a brief amount of time talking about how you use something called social network analysis to identify key informants. So this is a tool that can be used to help analyze social networks. So what you're seeing on the left, this is what looks like a constellation of dots and lines, and you may be asking yourself what this is. So what these dots represent are individuals in a network, and the lines are representative of ties or connections between those individuals. A lot of social network analyses, when you see the output, it looks just like what you're seeing. That's the visualization of a network map. And if you could imagine, if you had to interpret this map to someone, this can be kind of complicated to explain. So usually when you talk about social network analysis, you tend to focus on one specific area of the network map. Like for instance, in this case, I'm going to refer to this area here within this black square. Most people take a kind of a more of a focal approach to looking at social networks to try to understand them. So let's just say we were to zoom in on this portion of the network map. And what we see here is these circles are representative of any individual in a network, and these squares in gray are representative of people that are informing them of whatever kind of information you're interested in. Now, when you look at networks at this level, you're essentially looking at what they call ego networks. These are individual networks. This is a really good way of getting a sense of the social neighborhoods of individuals, seeing within the close proximity, who are they getting information from, who are they interacting with. Now, there's a couple of important metrics that can come from looking at the network maps at this level. One of them is something called out degree, which is really just an indication of the network size of an individual. So if you look at this example, one thing that you can take from it is, well, individual 1 has a greater out degree because they're connected to 1, 2, 3, 4, 5 informants relative to individuals 9 and 24. So that gives you an indication of how diverse and how large that individual's network is. Another thing that social network analysis can do is tell you who the important influencers are. So by this case, what you're looking for is to see which of these individual informants had more influence over this set of individuals. And so in this example, this enlarged square here, informant T, is more influential because it connects individuals to individuals 1, 9, and 24, and also based on the strength of that interaction. So the strength of the interaction is denoted by the width of the arrow. Okay. Now, I'm telling you about how to do analyses at a very kind of small micro scale. But if you were to pull out, let's say you wanted to look at a kind of a wider section of the network, you could look at something called the collective network or the social community. So here in this example, we have the same list of characters here on this left side, but we also have a separate group of individuals from essentially a different group. So individuals 8, 34, and 18 belong to a different, or could be a different organization. These groups could be based on gender. They could be based on geographical region, et cetera, any way that you want to differentiate these groups. Now, what's important here when you're looking at this perspective of a social network is that you can find out who are the important brokers. And I really want to hone in on this concept of what a broker is. A broker is simply an informant that connects different groups of individuals. So in this case here, you're seeing that this informant is connecting groups, this group with this group here. Why is this important? Well, it's often said, at least in the social network analysis world, that brokers are the most key people in a network. Why is that? Because they are effectively filling in gaps in the network. Without these people, these two groups would be disconnected and information would not flow. Okay. So I've given you a little bit of a primer here on what social network analyses are. I want to move into what our methodology is and what our results were. So how did we construct the social network analysis? We were interested in looking at integrated pest management practices among specialty crop producers in the Midwest. So we developed an online survey through Qualtrics. This survey was sent out via growers lists and via conferences. I think we also included the link to the survey through our Twitter accounts. And in the end, we ended up reaching approximately 700 producers across 8 states in the Midwest here in this region that you could see here in red. And we had, in that survey, we included a series of questions that were related to what practices they were utilizing. So we asked them questions on whether they were utilizing insecticide-based practices, whether they were actively engaging in monitoring and scouting, whether they were using cultural control practices, host plant resistance, classical and conservation biocontrol, and mating disruption. Not only did we ask them to self-identify their practices, but we also asked them what their social networks look like. And the key methodology for getting information on social networks is called a name generator question. So we included this question that asked them, all right, tell us who you are getting pest management information from. So name that in the individual or the group or the organization. Tell me what affiliation they have, what their job is, what their occupation is, and also on a scale of 0 to 3, let us know how influential this person is on your pest management decisions. Right? So I used a software platform called Polynode. This is available online. You can actually use it for free, depending on the number of analyses you want to do. Using Polynode is very, very intuitive. It's very simple. There's lots of great tutorials on how to use it through their online platform. We've calculated out degrees of the producers that took the surveys. We also looked for what informants were important influencers, and we also looked to see if we could identify brokers in this network. All right, now on to the results. So just from a general perspective from the survey, we were able to get responses from 62 specialty crop producers. Over half of them were from Michigan and Indiana. Most of them, the majority of them, were, I guess, medium to small scale producers growing on less than 50 acres. The majority of the crops fell into either 3 types of categories, either apiaceous crops, so celery, carrots, and parsley, cucurbits, including pumpkins, squash, and melons, and finally nightshades, including tomatoes, potatoes, and eggplant. And this is based on acreage. Now, as far as the pest management practices, we wanted to get an idea of what these producers were doing, what practices they were adopting. And so I'm going to present this information in terms of the diversity of practices that they were using. So we had a group of the 62 producers that we surveyed. We had about a little more than a third of them that fell into this group, which we call the low IPM diversity group. So these producers were really relying on pesticides. And you could see that in this graph here. This is a percentage of the practices that they used. So within this group of 23 producers, over 60% of the practices that they were utilizing were insecticide-based, as you can see highlighted here in yellow. We also had about almost a third of them that fell into this intermediate diversity group. And these producers were still using quite a bit of insecticides, but were also including some level of monitoring and cultural control. And finally, we had this high IPM diversity group, which is almost a third. Interestingly, we had like almost a perfect third split amongst the group that were utilizing insecticides, monitoring, cultural control, but also we're using a fair amount of host plant resistance and conservation biocontrol amongst their, slew of practices. Okay. I'm going to go back to the questions again that I showed you, and I want to show you the results of those. So again, one of our key questions that we're asking is, who are the key informants of IPM knowledge in these producer networks? So what I'm going to do here is show you the network, the full network. This is a network of 32 producers. And this is what it looked like. Okay, so these blue dots represent the individual producers that took the survey. These triangles are representative of their informants, and they're color-coded. So we have crop consultants here in brown. We have other producers here in this gold color. We had extension faculty Here in green, in purple, we had commercial suppliers, and in this pinkish, we had others. This is kind of, other is a way of saying non-human actors. Most of the times these were apps that were included in the other category. Now, one thing I want to take in looking at this, and one thing that you probably observed or picked up too, is if you compare this network to that example network that I showed you earlier, you can clearly see that there is not a lot of connection occurring amongst these 32 producers. So one of the key characteristics that we found is that there were few shared connections among this group of 32 producers. Polynode calculates something that's called network density, and what we found is that there were less than 1% of all possible connections were made. So the key point is here is this is a pretty disconnected group of producers. The second point that we want to make is that only less than 20%, so only 6 growers in this network of 32 producers had more than 2 people that they relied on for pest information. So most of these other producers relied on 1, maybe 2 people. A small percentage of them had more than 2 informants. So again, another key take-home point here is it's a disaggregated network, and most of these producers are relying on just a few people to get them information on pest management. Okay. I want to make sure I'm good on time here. So I'm going to try to go through this pretty fast. Influencers. We wanted to know who are the influential informants. So I'm going to show you 2 different types of maps right now that Polynode produced. When we're looking at individual influencers, so again, by definition, these are informants that had a lot of influence over producers within this surveyed group. We found that there were 5. 4 of those 5 informants worked in extension. So quite a few of them. We have 2 here from Michigan, 1 from Indiana, 1 from Ohio. And importantly, one of the other key informants was actually another producer. Okay. I'm going to show you another map here that gives you a slightly different, but essentially the same information. And that is when we look at affiliations. So again, we had, let's see here, 3, 2, 4, 5 different affiliations. Other producers, extension faculty, other commercial suppliers, crop consultants. What we found is that extension faculty were by far the most cited group of informants, followed by other producers. And you can see that based on the number of producer blue dots here connected with these informants. So we know that extension, other producers are important informants. Now, I told you that it's really one of the key results that you can find from doing these social network analyses is to identify brokers. So if we were to, let's say, spatially arrange the 32 producers into the 3 IPM categories that I had talked about earlier, with our low IPM diversity group here, all of our intermediate diversity group here, and our high IPM diversity group here, we found that there were 2 individuals that connected all 3 of these groups. One of them was an extension, and the other one was another producer. Coincidentally, maybe not so coincidentally, these were also some of the major influencers we found in that previous graph that I showed you. Okay, so what does that mean? That means that if we're looking to find those important bridges of IPM information within this network, really we're talking about these 2 individuals. All right. Now, I had one additional question. I'm going to get to this really quickly because I know we are tight on time. But that second question was, do producers with larger networks of informants adopt more diverse IPM practices? So we did a one-way analysis of variance, and we looked to see if there were significant differences in out degree. So out degree, again, is a number of connections between low, intermediate, and high IPM groups. Now, this is the result of that. So you have mean out degree here in the left, and the 3 groups here at the bottom. We found, interestingly, intermediate IPM group had a higher mean out degree, so they tended to have more informants in their networks. However, this difference was ultimately not significant. So to answer the question, do producers with larger networks of informants tend to adopt more diverse IPM practices? The answer is no, but when we look at what the possible role of the informants within those groups that had higher diversity, what we found is in the intermediate IPM diversity group, extension faculty were prominent informants. Again, these are the most cited affiliation of the 5 affiliations. And in the high IPM diversity group, it was again other producers. So I feel like I'm repeating the same information here multiple times. And I'm just going to conclude by saying that what were the kind of the main take-home points of our research? Well, we found that higher IPM diversity meant greater inclusion of cultural control, monitoring, host plant resistance, and conservation biocontrol practices. In terms of network diversity, we found that network size did not significantly differ between these producers from these 3 groups of IPM practice, but we continually find that there is a high importance and a prominent role of both extension and other producers in learning about IPM. So what I really want to end my portion of the talk with is by really highlighting particularly the role of other producers. So it's so incredibly important that in education that we incorporate the knowledge and the involvement of other producers, because these are key members of information networks. And I really think that this is summed up really nicely in this quote here that comes from the Journal of Rural Studies. And this quote says that farmers like to talk with other farmers about their farming practices as they consider their successful peers to be reliable experts because of their practical experience under comparable conditions. So people tend to learn from people that are like them. And I will leave it with that. And thank you all so much. I will see if I can figure out how to stop sharing here. All right.
Thank you so much for both of you sharing today during our webinar. We have a couple questions that have popped up in the Q&A bar, and just a reminder that it's at the bottom of your Zoom screen if you have more questions to add. Our first question was from Seth Dibley. Are trap rows surrounding the parsley fields a viable IPM tactic for this pest? And he also asked, what about soil fumigation between seasons?
Those are great questions. Trap rows, I actually think they would be a great tactic. No one's really tested it. I'm working with some celery growers who are really interested in trying this because the weevils we see an edge effect. So there tends to be more damage on the edge of fields, and the farther in you go, the less damage you see, at least in terms of plants being killed by the egg laying. So I think it's viable. The question is how many rows in, if you will, do we need to do that? Or maybe it could be something as, I was going to say simple, that might not be the best word, but something as simple as just, focusing on 5 or 6 edge rows with a certain strategy, like applying a soil applied drench that kills the larvae. So long story short, I don't have the answer, but I think that's a great possibility. In terms of soil fumigation, that is a great question. I don't know. I'm familiar at working with some of these commercial producers that they fumigate for diseases. So in terms of, safety and residues in the crop, I suspect it would be an option. I guess the question would be if they see it's feasible economically, if they feel it's worth their money. So I don't have a good answer there either, but I think those are 2 great questions that I'm going to have to ask.
Sounds good. Thank you. A second question from a mysterious listener. Social network analysis seems really important for IPM adoption. Have you personally used this evaluation in other IPM topics or crops other than carrot weevil and with vegetable growers? Are results similar based on crop and diseases, since there seems to be so much more information and knowledge sharing about other crops like corn and soybean and wheat compared to specialty crops?
Yeah, this is another really great question. So I'm going to be completely honest with you. I am new to the world of social network analyses. I just started learning this about a year ago, in the interest of trying to figure out a way to analyze this information that we've gotten from these surveys. And so I have not used it in other situations. I'm very interested in continuing to use it and to continue to learn about this. It's really a very evolving kind of piece of technology and analysis. So I have not used it before. I'm very curious to continue using it. I think that in the second part of the statement or question here about whether results would be very different based on crop and disease, I would 100%. I would 100% agree with that statement. I think that in some of the analyses that I'm currently doing now, we've looked at networks between specific groups of producers. Like we've looked at what the networks were between those that just produce nightshades, those that just produce cucurbits. And we're seeing some slight differences in the results there that would indicate that, yes, networks do change based on not only what crops are being grown, but also really on region, and a number of other factors. So to answer the question, yes, I do believe that the results differ. Right now, our network is kind of a smaller one. This particular network we looked at of 32 producers is really kind of a smaller network. It was based over a really wide geographical region. So when you look at that kind of data, it's more likely you're going to see less connections between the networks, only because it's a small group amongst a big region. However, I think it's still interesting to see that we see patterns in connections within a group of people that are really distantly located from each other and that are growing very different things. So yes, hopefully that answers that question.
Yeah, and a follow-up question to that. If someone was interested in getting involved in the social network analysis, how would you begin, or where can they get that software? I think you might have mentioned it during.
Yeah. So polynode.com, highly recommend it. That's where I would start. Is I would go to the website. You can sign up for a free account. So you don't need to pay in order to use the software. And they have various tutorials through that platform that you can watch. They're pretty short. They're 10, 15-minute long videos that will walk you through how to input the data, how to start analyzing it, ways that you can change the maps. And so it's pretty intuitive, but I would recommend starting with that site. And there's lots of great information on social networks, also on YouTube. So there's information out there without a doubt.
Yeah, thank you so much. Well, that's all our questions for today. And thank you so much again for sharing about carrot weevils and the social network analysis. Those are both pretty new topics to me, so I appreciate your time. And Seth Dibley also dropped an interesting comment into the chat for anyone that's curious to read it, kind of comparing some of this and the direction with crop consultants and chemical dealers that people rely on for some of the mainstay crops like corn and soybeans. So take a read there if you haven't already. And I just want to tell you that our next Pest in Progress webinar will be on Wednesday, August 21st at 12:30 p.m. Central or 1:30 Eastern. And Dr. Fabina Matthew will be sharing Phommosis stem canker of sunflower. Is fungicide resistance becoming an emerging problem? So we hope we'll see you all there. And thank you so much.
Thank you.
Bye.
Thank you.